here we go. Unit 8, Day 4. Let's see what you know and what you don't know. All right, it's going to start getting a little crazy. You got to start paying attention. You got to start working hard. You got to start memorizing a few things. You just got to know a few things, okay? So, let's talk. You know that sine of tangent is equal to, in terms of being an identity, or being that it is sine theta over cosine theta. You got to know that. You got to know that cotangent theta is cosine theta over sine theta. You got to know that cosecant theta is 1 over sine. In this case, we're using x. I'm not sure why I keep going back to theta. It should be using x, I guess. Secant x is 1 over cosine x. Here's one of the big ones right here. Sine squared x plus cosine squared x equals 1. And because you know that, you also know that 1 minus cosine squared x is equal to sine theta, or sine x, sine squared x. And 1 minus sine squared x is equal to cosine squared x. You know those just based on this one, right? We just move the cosine over or move the sine over. The new ones from yesterday and from what we did before was secant, or tangent squared plus 1 is secant squared x. And cotangent squared plus 1 is cosecant squared x. Get those memorized, children. Let's go, get them done. Because they make life easy. I'm going to do 10 questions and only 10 questions out of the 32. It looks like the other 22 will be yours for homework. I've tried to pick a few of the difficult ones and a few of the easy ones. For example, cotangent squared plus 1. I'm doing that one. Oh, that's just cosecant squared x. Done. What problem did I ask? What am I going to do next? 2. So, 2, I want to rewrite. Let's see. What we want to do is follow these simple steps. Is there a squared term? Is it a Pythagorean theorem? What can I do with it? Play around with this stuff. Can everything be turned into sine or cosine? Let's try. Cosecant is 1 over sine x times, tangent is sine x over cosine x times cosine x over 1. Well, now that I have everything in multiplication, I can start canceling things. The sines cancel and the cosines cancel. Well, it doesn't equal 0. Remember, this is going to equal 1. Everything gets canceled. It equals 1. Next one I was going to do was 3. Now, you know that tangent squared, I don't know why I just wrote it like that. Do you know that tangent squared x plus 1 is equal to secant squared x? So what we want to try to do is make this. Well, I think you see, if I bring this over here and then bring this over to this side, on this side I'll end up with 1 minus secant squared x. And then if I bring this over to the other side, just to kind of get, just so I have these two things on the left side, I get negative tangent squared x. And there's the answer to that question. That's what you want to do. All right, what's next? We're going to go to 8. Let's scroll down to 8. Ooh, man, this is something I probably want to look at my formula sheet for. I'm not going to, because I think by now you should probably have it memorized. This is 2 sine x cosine x, and then times cosine x minus 2 sine x. Now, this is a crazy, crazy problem. Well, isn't this 2 sine x times cosine squared x minus 2 sine x? And isn't cosine squared, I think I might have screwed this problem up, but isn't, not that I'm doing the bad work now, I think the original problem might have been screwed up. So this should be 2 sine x times 1 minus sine squared x. Because remember, we can replace cosine squared x with 1 minus sine squared x. So minus 2 sine x. We're almost done. We're going to distribute, so we get 2 sine x minus 2 sine squared x minus 2 sine, oh wait, this should be sine cubed x. Maybe I did get this right. Oops, I didn't finish. Sine x, sorry. Now this 2 sine x and this minus 2 sine x cancel. This should be cubed, by the way. So there's my answer. Negative 2 cubed sine x. Wow, that's a crazy problem. I'm going to 10 next. So what we want to do, it looks like we want to probably replace this. We always want to replace the double angles. And I'm going to replace it with something that kind of matches this. So 2 sine squared theta plus, let's see, go over to my formula sheet. I'm going to pick the one with sine in it. 1 minus 2 sine squared x. Let's try that one. 1 minus 2 sine squared theta. Well, this gives me 2 sine squared theta plus 1 minus 2 sine squared theta. Well, these just cancel. It looks like my answer is just 1. Sweet. What was next? 14. You think I'm doing the easy ones. I'm not really doing all the easy ones. I'm doing some of the hard ones. Ooh, this one looks tricky. So we're going to have to double distribute this. And we're going to have to double distribute this. Wow, that's a lot of work. Aren't you glad I did this one? Tan x plus 1. Tan x plus 1. I always have that kid who goes, let's just tan squared x plus 1. Yeah, right. Tan x minus 1. Tan x minus 1. So this gives me tan squared. This one's going to give me tan squared x plus 2 tan x. Now I'm not going to go through all that work. This is tan x and this is tan x. That's plus 2 tan x plus 1 plus, and this is going to give me tan squared x minus 2 tan x plus 1. So if I look at it, I think the 2 tan x's cancel, so I end up with 2 tan squared x plus 2. If I take out a 2, I'm left with 2 tan squared x plus 1, and isn't this secant squared? So my final answer is 2 secant squared x. Wow, that was a crazy hard one. All right, I got 3 left to do. No, 4 left to do, and then I'm done. All right, so these ones I want to make sure you understand how to do these. I'm going to go to 17. I'm going to go to 17. So what I have here is I have tan x. Oh, but can I rewrite tan x as sine x over cosine x? Thank you, I can. And then I can write this one as 1 over secant x. Now, we've talked a ton about, 1 over cosine. We've talked a ton about this already this year. When you have a fraction divided by a fraction, we flip and multiply. So what we end up with is sine x over cosine x times cosine x over 1. You flip and multiply. Well, the cosine x's cancel, and I'm left with sine x. Not bad. Not bad. 19. All right, so this one's kind of crazy. Let's see what we got here first. Let's replace everything. So this is sine x. I'm going to make it sine x over 1 times 1 over cosine x all over sine x over cosine x. Well, if I clean up the numerator, don't I get sine x over cosine x? That's the numerator, just multiply. And the denominator is sine x over cosine x. Well, isn't that the same thing over itself? That's just 1. 1. The next one I wanted to do was 28. Oh my gosh, crazy. I don't know why I picked this one. I have it on my list. So I'm going to make this sine of A times cosine of A times sine of A over cosine of A. Okay, cosine, these are all over 1, right? Cosine A's cancel. I'm left with sine squared A. Wow, this isn't bad. You guys can handle this. I think the last one I wanted to do was... Oh, I'm going to do 19 or 29 and... Oh, and then I got one I want to come back to because I think it's rather disgustingly difficult. We'll try it. So let's try this one. This is... Oh, I'm at the wrong problem. That's why I'm having problems. Okay, so it doesn't matter. I don't know why I picked this one. I picked 29? 29. Oh, it's 2. Okay, whatever. So this is really 2 sine squared A over sine A over cosine A. And then we're going to flip and multiply. So this is 2 sine squared A over 1 times, and we're going to flip and multiply, cosine A over sine A. Oops, that's a sine A. Well, it looks like the sine A's cancel. Wait a second, though. That one cancels with this one. Well, that leaves me 2 sine A times cosine A, but I was supposed to do it as just one function or one constant. So therefore, there's got to be something to this. And if you remember correctly, this is really just sine 2A, and that's your answer. That's why I want to do that. But I do want to go back to 20, so I'm going to actually do 11, because 20 looks difficult. So let's take a look at this. Cotangent. How are we going to write cotangent? How about we do it like this? Cosine squared x over sine squared x all over cosine squared x minus cosine squared x over cosine squared x. These just give me 1. This is an interesting one. This is really over 1, so I'm going to flip and multiply. So 1 over cosine squared x. Now my cosine squared x's cancel, and I'm left with these 1 over sine squared x minus 1. But wait a second, I'm not supposed to leave it like that. So this is really, let me come here, it's cosecant squared x minus 1. Do I have something for that? Cosecant squared x minus 1? No, but I know that cotangent, cotangent squared x plus 1 is equal to cosecant squared x. So what if I bring this 1 over? So don't I have cosecant squared minus 1, which is what I have here? And what's that equal to? It's equal to cotangent squared. Well, I leave the rest for you. Those are yours. I should have the answer key up on my website, mrkrausmath.com, at some point. Though the rest of my class is homework. Enjoy. Hopefully you do okay. If you like what you see, hit subscribe. If you don't know, if you want the answer key and I haven't provided it for you for this one, email me. I'll send it to you. That's at kenkrausmath.com. All right, guys. Nice job. Take it easy. Peace out.